Hey everybody, it's Mr. Swank. It's time for another Chemistry 1 lesson. Today is Tuesday, May 12th, and as always, we're going to start the day with a joke. You know, my friend told me he didn't understand cloning. I looked at him and I said, yeah, that makes two of us. Because, cloning makes two of us. Our objective for today is we're going to calculate different values with moles and particles. So yesterday, we talked about how a mole is similar to the idea of a dozen or a pair. It is a word to represent a specific amount. We know a dozen is 12. We know a pair is 2. A mole is 602 hextillion, or 6.02 times 10 to the 23rd. And in chemistry, we specifically use it to talk about the number of particles in something. Particles being atoms, molecules, or formula units. Now, today we're going to calculate with that number, which means, yes, we are doing math, but I'm going to help you through this, okay? So stick with me. We got this. So amounts aren't always perfect. You're not always going to have, say, exactly a dozen, or in the case of science, exactly a mole. When it comes to a dozen, think about it. How many eggs are in 2 dozen? Well, we know 1 dozen is 12, so how many in 2 dozen? Hopefully you said 24. You take 2 times the number in each dozen, which is 12. 2 times 12 is 24. Let's try something a little trickier. Let's say you have 30 eggs. How many dozen do you have? This is the opposite now. So we're going to take that 30 and we're going to divide it by the number in a dozen. 30 divided by 12 is 2.5. So you have 2.5 dozen. Now the same thing happens with moles and particles. You're not always going to have exactly 1 mole, and you're not always going to have 602 hextillion particles, okay? So we have to calculate with that. But keep in mind that the key to solving this is that idea that 1 mole is equal to 6.02 times 10 to the 23rd particles, okay? So how to set up mole calculations? Let's say you've got 2.4 moles of copper, okay? You want to figure out how many atoms are in that. Well, we know that our key to this is 1 mole is equal to 6.02 times 10 to the 23rd particles. Remember that particles are atoms, molecules, or formula units. So you can use particles, you can use atoms, molecules, or formula units, whatever you need to. But this is our key to getting from moles to atoms, okay? So what we're going to do is this. I'm going to show you my method for setting up conversions, which is what we're doing. We're converting from moles to atoms. Now you might be thinking, well, couldn't I just do this the way I did a dozen? You could, but the idea is as we move further into this chapter, these conversions are going to get more and more complicated and longer. And what I'm going to show you is a way to organize all this, to kind of organize your thoughts. Now you might be going, oh, why do I have to do this? You don't have to. Keep in mind, I'm never going to make you do things my way, but I show you a way that is the easiest, okay? So you're not just rushing through it. Take your time so you can get the right answer, okay? Especially if you're going on to Chem 2 or AP Chem, because you're going to do a lot of this there. And if you don't have a handle on this, you're going to fall behind. So make sure that for the next few weeks, you really pay attention and focus on this. And if you have problems with this, please contact me. But let's try this because it's not too difficult, okay? Just follow my method. So the method I'm going to use is called the boxes. The boxes, basically, we're going to start with a big plus sign like that, okay? And what you've got there is you've got 4 boxes. There, 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 and there. And we use those to kind of organize our numbers so we can set up the math and know what we're calculating, okay? So we're going to start in the top left here. What number is going to go there? Well, if you go back to your problem, it said how many atoms are in 2.40 moles of copper. So we're going to take that number we started with, the number in the problem, we're going to bring it down, and that goes in the top left. Your starting number, the number you're converting, always goes in the top left. So whatever number was in your problem goes right there, okay? The bottom left box here, just block it out. Scribble it out, whatever you want. We're not going to use that box, okay? That leaves us with 2 boxes here, and we still have 2 numbers. We have 1 mole and 6.02 times 10 to the 23rd particles. So what is going to go where? Well, this is where the boxes help you organize it. Because when you do the boxes, you want the top left and the bottom right to match in terms of units. What unit do we have here? We have moles. If moles are in the top left, we want mole in the bottom right. Okay? So those are there. Now, why do we want to do that? That's because what did the problem ask us to find? It asked us to find atoms. We're in moles. We don't want to be in moles anymore. Now you could treat this just like a fraction. If you have something on top, it's the same as something on the bottom. You can cross them out. That gets rid of our moles. Our numbers are still there, but our units are gone. Now we've got a space up here. What goes there? Well, if we have 1 mole on the bottom, what's 1 mole equal to? 6.02 times 10 to the 23rd particles, or atoms, molecules, or formula units. In this case, what are we looking for? Atoms. But we can leave it as particles. That's perfectly fine. Our numbers are all in the spots we need them to be, okay? And all we did was we put our starting number here and use that to direct the rest of it. Remember, moles are up here. We want mole diagonal to it so they cancel, and whatever 1 mole is equal to goes on top for this one, okay? Now that it's set up, what are you going to do? Well, we got to do a little bit of math now. Across the top and the bottom, we're going to multiply across, okay? So 2.40 times 6.02 times 10 to the 23rd particles gives us, and you can punch this into the calculator, you get 1.44 times 10 to the 24th particles, okay? Now we still have stuff on the bottom. So over top of, well, what's across the bottom? Well, we don't multiply anything here because we only have the one number. And what is it? It's 1. We're not done yet because now we got to clean it up. 1.44 times 10 to the 24th particles over 1, what's that equal to? 1.44 times 10 to the 24th particles. And that is how you do one of these problems, okay? Now, the idea here is, did you have to put 1 on the bottom? No, but are you always going to have 1 on the bottom? No. It all depends on what you're starting with. And we're going to see that in our next problem. You have 3.4 times 10 to the 24th atoms of xenon. How many moles do you have? Okay, so very similar problem. We've got particles, we've got moles, which means we're using 1 mole equals 6.02 times 10 to the 23rd particles. And remember, this is always set up like this. It's always going to be 1 mole and 6.02 times 10 to the 23rd particles. Set up our boxes, okay? Next, we take our starting number from the problem, 3.4 times 10 to the 24th atoms. That goes in the top left. We black out our bottom left box, okay? Now this is where it gets tricky because now look at our starting unit. We have atoms. We want a unit to cancel out down here. We've got mole, we've got particles. Neither one is exactly atoms written there, but remember, particles are also atoms. That means if atoms are here, we want particles or atoms down there. That means this time 6.02 times 10 to the 23rd is on the bottom. You see what happened there? It's not the same as the last problem. You have to use those starting units to dictate what's going to go where. You want these to match. Atoms and particles are the same thing, so they cancel. If 6.02 times 10 to the 23rd is on the bottom, what goes on top? 1 mole. Okay? We're always going to have these two together. 1 mole and 6.02 times 10 to the 23rd particles, at least in this case. Okay? Equals. So again, we multiply across the top. 3.4 times 10 to the 24th times 1 mole gives us 3.4 times 10 to the 24th moles, because it's just that times 1. Now we have moles. Over what's on the bottom? 6.02 times 10 to the 23rd. Top divided by bottom, you end up with 5.6. Okay? So you take that top number divided by the bottom number, and there's your answer. I know this seems tricky, guys, and if you're having trouble, please go back through the video, watch how I set it up again. But the key to this is you always want whatever your starting unit is in the top left to match whatever's in the bottom right. And for right now, you're just using 1 mole and 6.02 times 10 to the 23rd particles, okay? There's a couple of problems to try. Make sure to get that done, and good luck. If you have any questions, please message me, comment, whatever. I will try to help you through it. But don't feel like you have to watch the video just once and get it automatically, okay? Go back, rewatch the video. Watch how I do these problems, okay? See if you can get this set up. And if you'd like to, try and set up the problems on your own, okay? Hope you have a great day, everyone. I'll catch you tomorrow.